Okay, we'll be starting with IPv4 address. Let us have a look at it. IPv4 address. Now, it's a 32-bit logical address assigned to a network device. The few words that we want to focus here is 32 bits. The first thing that you need to understand, what is a bit? I think you already know. So bits are something like 0 and 1. So 0 is 1 bit, 1 is 1 bit. Okay. Now, when I say each of them is a bit, when I say 32 bits, that means you have a combination of 32 zeros, like it's a combination of zeros and ones, but it has to be 32. So let me just do like this way. Let me just write something 0 1 0 1 0 1 0 1. Let me also write something like 1 0 1 0 1 0 1 0. Let me write something like 0 0 0 0 0 0 0 0. Let me also write something like 1 1 1 1 1 1 1 1. Okay. Now you can see like I have put some gaps between them. I will come to that point later. Okay, so don't worry about it. Logical address means it can be assigned to any device at any point in time. Okay. Now that's not true. Okay, but I'm just saying logical. Okay. So you can assign it. Okay. Now, like that is what we are going to learn. Okay, with time, like what IP address you can assign where and what IP address you cannot assign where. Now, look at here very carefully. We configure it on a network device, and mostly it will be configured on an interface. The another name could be port. The another name of the interface is port. Okay, as well. So you can configure it on a port, you can configure it on an interface, they're the same thing. Okay. If you look at here, is written in decimal format with 4 octets separated by dots. Now, for example, 192.168.1.1. Look at here very carefully. This is binary format. And what is the decimal format? It will be something like this, 192.168.1.1. Let me write here, what's the decimal format? 192.168.1.1. It is the decimal format. Now, if you see something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever is the number, that means that's the decimal format. And if you see zeros and ones, that means it's a binary. Now, don't get confused like this one is a binary, okay? Because you can look at the pattern and you can see it's like 192.168. It will be not something like 0101 binary, okay? So you cannot have a combination of binary and decimal. For the purpose of understanding, I may use combination of binary and decimal, because the reason is if I want to write everything in binary, let's say if I have 128-bit and which is IPv6. Now if you look at here, this is IPv4, which is 32-bit, and IPv6, this is something you'll not read now, maybe at a point in time, then it will be 128 bits. Okay, so I won't be able to write 128 bits like 010101 and all like this way. Okay, so in that case I will put for the purpose of understanding, but when you write decimal, it's completely decimal. When you work with binary, it's completely binary. Now the question is this 192? No. Is this 168? No. Is this 1? No. Is this 1? No. So I just wanted to give an example, the difference between binary and decimal. So this is surely not 192. This is surely not 168. This is surely not 0. This is surely not 1. Okay. Now you know what is binary and decimal. But however, if you convert this, it will be if you convert this, it will produce a decimal. If you convert this, it will produce a decimal. If you convert this, it will produce a decimal. If you convert this, it will produce a decimal. And that decimal, and if you look at here what it says, it's a 4 octets. Focus on the word octets. Octets means 8 bits. So that is why I actually put them in this way, and they are separated by a dots. So if you look at here, so you will get a dot here, a dot here, a dot here. And if you look at here, there are 8 bits, there are 8 bits, there are 8 bits, there are 8 bits. So that is called octets. If you add them all together, you will find 32 bits. Now we will learn conversion later. We will learn conversion later, but for the time being, not. Okay, I don't want to put everything in one place. Just have a look here. Okay, now if you look at here very carefully, what will be the decimal format of this number? So it will be, I think, if I'm not making a mistake, 85. Okay, look, we can do this conversion like once we do the conversion, like we'll have a look at that one later. But for the time being, I think it will be 85, and it will be 170, it will be 0, and it will be 255. Okay, the conversion will look like this. And in the same way, the conversion of 85 will be this to binary, 170 will be this, 0 will be this, and 255 will be this. Okay, I think you've got a little bit of idea what's IP address and what it looks like. Okay, so if you look at here, every number can be represented 8 binary bits. It is already clear. So every number is 8 binary bits, 8 binary bits, 8 binary bits, 8 binary bits, and hence we call it an octet. Now, if you look at here, the total number of possible IP addresses is 2 to the power 32, because you have got 32 bits. Okay, not all IP addresses are usable or routable over the internet. Now, this is important. If you come here for this particular line, there is something called private IP address, which is 32 bits, and there is something called public IP address, which is also 32 bits. There is no problem. They all look the same. Okay, so what is private IP address? They are not routable on the internet. They are only used on LAN. Okay, and public IP address, you see, not all the IP addresses are usable or routable over the internet. Okay, so public IP addresses, they are routable over the internet. Okay, now what happens if you want to route a private IP address over the internet? Your ISP will block it, because internet is something that you don't control. It is controlled by your ISP. Now, when I'm saying about ISP, think about Optus, think about TPG, think about Telstra. Okay, it is for free, and you need to pay for it. And like you can write any of the private IP address. There are private IP address range, and it's up to you. It's up to you. But this is something is not up to you. It is up to the ISP. What the ISP gives you. Okay. So you cannot. You may request for an IP address. If they have, they will give you. If they don't have, they can't give you. Okay. Now IPv4. Now look at here very carefully. Don't get confused with this public and the private IP address. IPv4 can be divided into 5 different classes. Okay, so private and public is of course there, but IPv4 addresses can be divided into 5 different classes: A, B, C, D, and E. This is something have to be memorized. And if you look at here very carefully, like just remember IPv4 address, like the lowest you can have in the address is 0, and the highest you can have in the address is 255. And if you look at here very carefully, you see all zeros produces only 0, and all ones it produces only 255. So actually you cannot have less than 0 and you cannot have more than 255. So if someone gives you an IP address which is more than 255, it's an invalid IP address. Okay. Now this is the range for A, 0.0.0 to 127.255.255.255. Now let me take this number and look at here very carefully. The starting or the first one is 0.0.0.0.0.0, and the last one is 127.255.255.255. Now look at here, if someone gives you an IP address which is 1.5.200.255, and someone gave you another IP addresses which is 195.0.2.1. The first thing that you will try is this IP address you can fit in between this or not. If you can fit this, this is a class A IP address. Can I fit this IP address in between? This is a class A, I know that. Can I fit this IP address in between them? 195, so it says the initial is 0 and the last one is 127. Can I fit 195 between 0? No, 195 is beyond 127. So this is not a class A. This is not a class A. So this is how you know an IP address belongs to which class. An IP address belongs to which class. Okay. Similarly, you need to memorize for class B is 128.000.191.255.255.255. For class C, 192.000 to 223.255.255.255. Now, mostly we will be working with these 3 classes. Okay. Class D is reserved for multicast. It is mostly for voice and video. Okay. So if you do CCNA collaboration, okay, CCNP collaboration, you will need about this one. And class C is used for experimental purpose, which you can say research and development. Okay, so mostly you will not be using class D and class C. However, you need to know what is class D and class C is and the range. Okay, but however, we will not use them. Okay, I think. So if you want to assign an IP address to a device, you'll have to choose from either one of them. Now, from each of the classes, we have some IP address like public or private. So we will learn those things. Okay, in one of the videos, we'll learn. In one of the classes, we'll learn what is the public IP address and what is the private IP address. Okay, there is something called RFC 1918 address. RFC is a standard 1980 address. So this standard has been given to the private IP address. Now look at here very carefully. In each of the three classes, you have a block of IP address that is reserved as the private IP address. We already discussed what is private IP addresses. A few characteristics of the private IP addresses is not routable over the internet. Very important, over the internet. It is routable inside, okay, not over the internet. Inside means inside the LAN. It is used only in the LAN, okay. It is for free, as long as you know how to create that one, okay, how to use that one. You can produce your one as well. You can produce your one. You can have duplicate IP address. You can have duplicate IP address. You can have duplicate IP address in different LANs, not in the same, in different, okay, in different LANs, but not in the same LAN, okay. Now look at here very carefully. IP address is a number that actually identifies a device. So if you have two devices with the same number, let's say you have two devices with the same number and they're in the same location, then how can you identify who is who, okay? So that is why you cannot have this. So you can have a different number, okay, as long as there are certain rules, okay, you can follow it, it will work. Yes, they can be used by anyone, doesn't matter. RFC 1990 address helps to conserve the IP. Okay, now look at here very carefully here. Why we need private and why we need public? That's the first question. Like, why does the private exist? If you look at the IP address, okay, if you look at this IP address thing, like, there is a limitation. There is only 32 bits, okay, and you can have 2 to the power 32. Like, how many? Like, I don't know, like something million or something. But if you look, like, a person is using 10-20 devices, even the watch is having an IP address, even the refrigerators with the IoT, everyone is having, like, at a home you go, they need 100 IP addresses, okay. So if you are not having the private and if you are not having the duplicate IP addresses, then you will run out of, you would have run out of IP addresses a long time ago. So that is why we actually need public and private, because public IP addresses are unique, unlike the private IP addresses, and there is no duplication of the public IP addresses. I think it should clear a little bit about the private IP addresses. It is very important. It is always now the question comes, what are the private IP addresses? Okay, so we need to know, like, we need to create the public IP address. We need to create the private IP addresses, and we need to use the private IP addresses at our home. So we need to know the range. Now look at here very carefully. This is the range for the private IP addresses. The first thing, you come here. You get this one. Okay, let's get this one. Okay, let's get this one. Let's get this one. Copy this one here, bring it here, put it here. Now look at here very carefully. The whole thing is the class A. So in class A, see, if you look at here, if I write this number 10.0.0.0 and it is 10.255.255.255. This is the full class A, and this is the private portion of the class A. Now look at here very carefully. You see where is, so if you look at here, where is 1, where is 2, where is 3, where is 4, where is 5? They are missing. So they are the part of the public IP address. They are the part of the public IP address. So if you compare here, it's 10, and here is also 10. So is there any range? Like for example, think like it is 12. So if it had been 12, so there had been a range of 2, right? Like 2 numbers, 10, 11, 12, actually 3 numbers. But there is no range here, right? So it's all 10, okay? So only any number that starts with 10 is a private IP address. And if you look at here, this is the private IP address. You memorize the range for the private IP address. You memorize the range for the private IP address, and any number that is not a part of the private IP address is a public IP address. Public IP address of which class, A, B, or C? The public IP address for class A, okay, depending on what you have here. In the same way, if you come here and if you take this one as well, class B, class C, okay, as well. So if you take here class B, C, because that is what we need only. Let me just take it there. So if you look at here, 128 to 191. But if you look at here, it is 172. It starts with 172 here, which is 172, and it also ends with 172 here, okay, which is 172. So if you find, but here you have range, right? So any number in this block of IP address matches with this IP address is a private IP address. Private for whom? Private for class B. Private for class B. In the same way, this is class C. So if you look at here, this one to this one, 192 to 223. So if you look at here, sorry, this is class C address. This is the full class C address. However, the private portion is 192.168.0.0. Now, very important to understand here, if you get a number 192.170.0.0, this is not private. This becomes public. Why this is public? Because if you, okay, now there is a question here. We didn't write the end one, so you might get confused. So the end one is 192.168.255.255. So if you look at here very carefully, the first portion matched. 192, yes. 192 match. 168 and 168. So if you look at here, 170 doesn't match with either of the 168 because this is the starting number, this is the ending number. So actually this is a public IP address. In this way you can find a number whether it's a private IP address or it's a public IP address. Now there is something called loopback address. The loopback address is always fixed. The entire 127.0.0/8. What does it mean? It starts with 127.0.0.0 and it ends with 127.255.255.255. So the entire range, okay? So this is the starting. So if I get a number which is 127.190.50.60. So if you look at here, this number fall in this range. 127 matches with 127, all good. 190, is it between 0 to 255? Yes. 50, is it between 0 to 255? Yes. 60, is it between 0 to 255? Yes. So this fall in this range. So entire block is the loopback address. Now look at here very carefully. The concept of loopback address is very complex. But however, in order to make it simple and whatever you need to know initially is loopback address is own IP address. So if you have a computer, your computer will of course have an IP address which is private IP address, and it could be, let's say, 192.168.1.5. In addition, the whole lot of IP address that you can see here, okay, the whole lot of IP address you can see here is also his own IP address. So any loopback address which starts with 127, okay, is the own IP address. Okay, so this computer has maybe a few thousands or millions IP addresses of its own. Now look at here very carefully. Loopback address concepts goes beyond. We are not going into that. So any loopback address is like if you ping, it actually comes back to you. Okay, so if you ping 127.0.5.6, it will come back to you. If you ping 127.255.255.5, it will actually come back to you. So all the IP address is in this range belongs to the own device. So if you have 100 devices, let's say if you have 100 devices, all the devices will have the same thing. They actually don't go from one device to the other device. They actually comes here. So if you ping, like if this person pings 127.0.0.1, it comes to him. If this person pings 127.0.0.1, it comes back to him. If this person pings the same number 127.0.0.1, it actually comes back to him. This is the concept of the loopback address. But however, you can see loopback address like 1.1.15. Now I said don't worry much about the loopback address just for the time being. Initially, you just need to learn about this in the loopback address.